All right, let's go ahead and get started. Good morning, good afternoon, good evening. Welcome to to the latest in our CA IDMS educational webcast series. My name is Len Thompson. I am CA's Mainframe Community Manager, for those of you who do not know me. Real quick before we get started and I hand you off to Dick, if you have any questions throughout the session, I see most of you are in the audio broadcast, so please use the Q&A box right in the WebEx to ask any questions you might have. You should see that box in the lower right of your screen. If you don't see it, if you mouse over the lower part of the screen, you should see a series of circular icons. One should be a question mark. Go ahead and click that, and it will open up for you. Feel free to use that throughout the session. We will hold all questions to the end, and if for whatever reason we can't answer all the questions by the end of our time, I will capture the questions, and we'll make sure that either Dick or I follow up with you after the fact. With that little bit out of the way, I'm going to hand you off to Dick, so take it away, Dick.
Thank you, Len. Give me a second, folks, so I position our slides. Well, let's do it. There we go. Okay, last week we were talking about restructuring the database using the Restructure and Restructure Connect utilities. And one of the things that I mentioned in there was that the Restructure utility is driven by a table that defines the changes being made to the database, and that table is the IDMS RSTT table. Actually, you have the ability to give that whatever name you want, but by default we'll be talking about it as IDMS RSTT. That table is actually built with a number of assembler macros, and I know a lot of people may not be familiar with assembler languages. So what we have is a utility called IDMS RSTC that will actually go through and create this table for you. And it does this by comparing the old and the new schema definitions. So the IDMS, what we have here on our slide, is a diagram of the RSTC execution environment. The input, as most of our other parameters, comes in through sysIPT, and an output listing comes out through syslist. IDMS RSTC is actually a standalone utility, so it is the program that you will specify on your exec program equal statement for the individual job step. IDMS RSTC reads the data dictionary as input, and along with the syslist listing, will also write the source out to a sequential file. That sequential file is specified or defined on the syspchdd name, and once that file is created, you will then take that as source input into your site's assembler and link edit routines, and that will create a load module that will be used by the actual Restructure utility. Now, a couple things with IDMS RSTC. IDMS RSTC runs in either batch or batch CV or batch local mode. It only reads the data dictionary. It does no updating. So it really has no impact on your existing runtime environment. It can be run at any point in time. You don't have to worry about backing up anything. So it's just a matter of executing that particular utility. The input to that utility consists of the old view of the database and the new view of the database. In other words, the new schema or the schema that defines the changes that you're trying to implement within that database. Now, the IDMS RSTT macros that are generated should be reviewed for accuracy. In many cases, well, in most of the cases, let's say, you will always have accurate generations of the changes. The one area that does have an impact on RSTC is records that have redefined statements within them. I worked for a long time back in the 90s trying to get that thing to deal with it, but there are some things that it just will have a little bit of problem with. And what we've done is create some messages that will be generated as part of the output, so that you can at least be identified that there are RSTC or there are redefines that are involved. If you have any problems understanding what is being generated there, feel free to call Level 1, and they can walk you through it and verify the contents of the RSTT macros. But again, I would say in probably 98% of the processes, you won't have any problems with that structure. Again, one of the things that is possible within RSTC is that you can actually define multiple pairs of schemas. So that if you're going to have 2 or 3 different schemas that are being updated, you can run them all at one point in time. However, you have to make sure that you separate those macros based on the individual schemas before you run them through your assembler and create your load module. So I strongly recommend that if you have multiple schemas that are being processed for different databases, run them as separate executions specifying just one schema subschema pair. But I do want to mention that it is possible and prevent you from maybe having some problems by trying to run them all through one assembler execution. Now, the steps to run IDMS RSTC are pretty straightforward. You're going to be making changes to a database, and again, the database is defined by the schema. So you're going to want to go through and create a schema that describes the new description of that database. So that would be changing elements, lengths, positions, getting rid of records, changing sets, adding, getting rid of sets, whatever the changes may be. So define that. Those changes into a new schema. You'll then run IDMS RSTC specifying in the input syntax the old and the new schemas, and then once again review the IDMS RSTT macros for accuracy. Take the output that's in the sequential file and run that in as the source into your local assembler, and then create an object module, link edit that object module into a load library as a load module. Now, what we're going to take a look at here is just to give you an idea of what one of these RSTT sets of macros will generate. Now, this is actually the syslist output. And the distinction here are those first 3 lines. It echoes back the syntax that you've specified. So the output that goes to the sequential file will not have those first 3 lines. It would just start with the IDMS RSTT buff size line. So what we have here, the first line on that is the IDMS RSTT buff size, and this is going to tell the Restructure utility the size of the input buffer for the old records and the size of the output buffer for the new records. Again, your records are going to be different sizes. This is going to be the maximum size records that are going to be processed as a result of dealing with the specified schemas. Then for every record within the schema, it is going to go through and generate an IDMS RSTT rec name equals, where rec name equals then specifies the name of the record. So as we see here on this slide, the AA, that's the name of the record. You'll see that we actually have 2 of these. A little further down, you can see a rec name BB. So you will get one of these for every record within the schema, even if that record or a given record has not had any changes made to it. So it gives you the entire schema listing. Then any changes to the sets involved with a particular record will be identified through IDMS RSTT set pointer statements. Any set pointer is telling you about changes with a given set. In this particular case, we're going to change the, for the owner, we're going to be adding a prior pointer. So the first thing we're going to do is the existing pointer is a next. This first statement tells us that position 1 in the old record is going to be moved to position 2 in the new record. We're adding the prior pointer, and it's being added into an owner record. So the set pointer is going to specify an asterisk because it's an owner. It's in the owner record. It's going to put it in position 2 in the prefix for the AA record, and it's specifying the name of the set that's being involved. There are no changes to the actual fields or data fields within the record. So in this particular case, the RSTC will just generate a field, IDMS RSTT field equals all. So that basically is going to tell the restructure utility to take the existing data of the record, move it as is into the new record, so there will be no changes. If you are not making any changes to the set pointers, you would also specify a set pointer equals all. So you don't have to get down into the detail of these various parameters unless there are changes to the prefixes or the fields. Now in the Rec B, the second record, this is a variable length record. The DCT equals built-in would be an indication that this record was being compressed and decompressed by PressPack. And because it's a variable length record, it also specifies minimum lengths for minimum and maximum lengths and control lengths for the records. Again, this is something that RSTC will calculate for you. You don't have to make any change or make any calculations for that. We're also adding the prior pointers plus an owner pointer to this record, so you can see we have 2 additional set pointers. The fact that we just have a comma with no asterisk in it tells us that this is a member record of the AB set, and we're adding a new pointer. And in this particular case, there is another pointer within that record that was at position 2. It was for an index called IXBB. The pointer that was at index position 2 is now going to be moved to position 4. These are all based on the changes that you made to the schema. We then have 2 field statements, even though in this particular case we're not actually changing the data. This is a variable length record, and there are control lengths within the record. So the RSTC parameter or utility is going to define the first field as the control length of that particular record, and then the second field is the field statement is the remainder of that record. Any changes to the data would have field statements similar to what you see here. We then finish up with an IDMS RSTT end parameter. This is something specific to the restructure utility. It's going to tell the restructure utility that it's come to the end of the table for the particular restructure that's being executed, and this second end statement at the very conclusion of the parameters is an assembler statement which will be used by the assembler as it goes through the assembly process. So that more or less concludes our talk of actually using the restructure utility. But there are some other changes that can be made to the database that you actually can use the maintain index for. We have talked about maintain index earlier in the WebExes, talking about basically expanding the areas that are involved with indexes. But there are some changes to index structures that can actually be implemented using the maintain index utility. So you don't have to go through and unload, reload databases. You could just handle specific indexes that are being altered. And those changes we see here are that you can change the fields making up an index key. Potentially, you have an index that just specifies the sort key as field 1, but you now want to add another field and make that a concatenated key. So again, maintain index could be used to rebuild that index and it will go out and specify or create that key based on the two fields making that concatenated key. The index order can be changed, so you could change something from sorted to say next or any type of unsorted, or from unsorted to a sorted key, and change the IBC, the index block count. Again, I mentioned some time back, the IBC or index block count is the number of entries within a particular SR8. So you may have decided that the initial calculations of that value may not be ideal, may be too large or too small, so it can be changed once again using maintain index. And then finally, you can also change the area in which an index structure resides. So we're going to look at the procedures for running maintain index for each of these various types of changes. So the general steps to run maintain index. The first one is modify the database definition of the index. So again, the number of entries in an SR8 can be specified within the schema. You would also specify within the schema the keys or the fields that make up index keys. So you make those changes within the schema, and then you want to create and regenerate all of the various subschemas involved with that particular schema. You'll want to vary the index areas and data areas involved with the index offline from any active CVs. Maintain index executes as a local utility, which means that it can be the only copy of IDMS that has access to those areas during the maintain index process. So again, either varying them off from the index or just making sure that nobody else has access to those areas. Like any other process, we want to make sure we back up the affected areas in case we have some type of a problem. And now we're going to start looking at some of the various things to do with these specific types of changes. So if we're changing the key structure or the order of the index, you're going to run maintain index in the following manner. You'll want to use the subschema with the new definition of the index, and then use the rebuild from members or rebuild from all rows options. What this is going to do is process this database by looking at all of the data records that are part of that index or indexed by that definition. And when it does the from members or from all rows, it will go out and extract the key information from the actual data records themselves. Maintain index will then delete the existing index, and using the new subschema definition, build that new index based on the characteristics that you've just defined for that within that new schema. If you've decided what you want to do is you want to change the area in which an index resides. For example, it's not unusual that initially people defined indexes within the same area as the data, but they may have determined that there's some performance hits that they're taking with that, and so they want to move the index into its own index area. So if that's the type of thing that you're going to be doing, you're going to actually run the maintain index in two basic steps. The first one is you will run using the subschema that defines the old definition of the database. So in this particular case, we know that the index keys and everything are going to stay the same. All we want to do is move it. So we will specify, or we will run maintain index, specifying in the input parameters step IDMS TBAX, and also rebuild from index. Rebuild from index allows us to extract the key information from the existing index. It's much faster than going through and using the from members or all rows. However, I should point out it is totally legitimate that you could do a rebuild from all members or all rows. It's just that in that case, we will extract the key information from the database records as opposed to the index. But the rebuild from index will always be a faster process. At the completion of that particular job step, and that the step IDMS tab X tells maintain index to only run that extraction step. Then you will run a second job step And in the input parameters for that, you will specify from sort 3. From sort 3 tells maintain index to start the rebuild process from basically in the middle, from the part that's actually going to rebuild the index. So at this point in time, it will delete the old index structure and then build that index structure in the new area. This second job step will use the subschema that defines the new definition of the index. At the completion of running the maintain index, and again, we've seen these steps before, validate the database, whether it be DBAN, print spaces, OLQ, culprits, running some of your own applications to make sure that they're now getting the information using the new subschemas. Back up the affected areas in case someplace later on after we've been processing we have to do a recovery. We want to be able to recover from the point after the maintain index so we don't have to repeat that process. You'll want to migrate any of your modified subschemas or programs to the appropriate environment. Some of those programs may be changed because now you're going to maybe add an additional field into a key. So their programs are going to have to build a new key if they're doing some type of a direct retrieval by key. So migrate those modified subschemas or programs to the various environments. And then you can vary the areas back into an update mode or make them available to any of your application processes. Now, one of the things that always comes up as a question to level 1 in many cases is what programs are going to be affected by your various changes? And so here we have a list of the types of changes that you might make, and these will generally require some type of at least review of the application programs, not necessarily always requiring the changing of the programs, and we'll be talking about that in just a second. But these first 3 on this list, these are probably ones that are for the most part, going to require some type of minimally a recompilation. So here we're going to be talking about inserting new data items into a record, deleting existing data elements, so we're changing the length of the record or changing the length and positions of data elements within the records. So all 3 of those, there is an impact on the length of the records. So your programs are going to define a certain amount of space to contain that record when it's moved from IDMS into your application program. So if you don't go through and do a recompilation, the possibility exists that, let's say if you add a new element, we're going to be adding, or we're going to be returning a larger record to you, and you can end up overlaying storage after the buffer area assigned to that particular record. So you want that program to have the proper amount of space defined for the records buffer within the program. We're going to be looking at these, looking at some of these scenarios in just a second here, and talking about some ways to minimize the impact or minimize the number of programs that may have to be modified for these first 3. Changing the format of a record from fixed to variable length or from variable to fixed length may require change of a program. This really depends on what we're talking about in terms of a variable length record. There are 2 things that can make a record variable. One of those is that it's compressed. Now, if you're getting rid of compression or adding compression, that is totally transparent to application programs. So even though that change of, let's say, adding compression to a record makes it a variable length record, you don't have to worry about redoing the programs because, again, that's transparent. The other way that you have a variable length record is by the presence of an occurs depending on clause within the program. And that is, I think, what people are more familiar with when they're dealing with variable length records. So if that is the change that you're making, you're adding an occurs depending on or removing it and making it a fixed length record, that in that particular case, you're going to want to go through and recompile those programs. These last 3 are talking about set relationships. adding new sets, deleting sets, or adding pointers to existing sets. Now, if a program does not use the altered set, there's typically no reason that you have to go through and recompile that program. Even if the program has the set names defined in it, if you're not using it, they're not going to be affected. But if a program is going to use the new set, of course, it's going to have changes made to it to account for that new set. If it was using a set being deleted, of course, you're going to have to change the program to alter or change it so that it doesn't try and use the set that's being eliminated. Now, this last one, adding or deleting prior or owner pointers for existing sets. This really gets into more or less the discussion of the prior pointers. Programs, if they are going to walk the set in a backwards way, either say, let's say, find or obtain last or find or obtain prior, they must have prior pointers defined to those records. So if you have prior pointers and for some reason you've decided you're going to get rid of them, if there are any programs that do find or obtain last or prior processing, they will have to be altered because those commands will no longer function without the prior pointers. If you're going to add prior pointers and because now you want to walk in a backwards direction through a set, of course, you're going to make those changes. Owner pointers in most cases are going to be transparent. You can do an obtain owner on a set that does not have owner pointers. However, it is very inefficient, especially if it's a non-via set. So by adding the owner pointers, all you're going to end up doing is making that obtain or find owner command more efficient. So you don't always have to do the recompile the programs just because you've added owner pointers. Now, one of the things that can lessen the need or lessen the number of programs that are going to be recompiled when you're adding or dropping elements from a record depends on how you've coded your subschemas. Let's take a quick look at this slide. This is just to show you the changes that we're making to our particular record. So on the left-hand side, we have the original record, and that record is made up of 3 fields, field 1, field 2, field 3. They're each 10 bytes in length. The change that I'm making to the database is adding a field 4 to that record's definition. Now, most sites, and I will admit when I was a DBA, it was the way that I initially did it because it was easier, it was shorter. What I did is I just said add record name is record A, period. And that's all I put into the subschema. Now, if that's all I've specified within my particular subschema's definition, when that subschema is compiled, it will bring in all of the fields that are defined on the record. And so what we would have on the original or the old subschema would be 3 fields that are 10 bytes each. So we bring in a field or bring in a record that had 30 bytes worth of space in the buffer. The new subschema, when it would be generated using just the add record name as record A, it now brings in 4 fields that are 10 bytes. That program is going to have 40 bytes. So if that's all I do, is I just, in the subschema, say add record name as record A, period, that means that I'm going to have to go through and recompile every program that uses that subschema. Now, just to make sure that I have enough space and that I don't overlay something after the buffer area for record A. However, what we see on this particular slide is instead of ending the statement on the add record statement is, we continue with a clause called elements are. And you can list the various elements in the record. So here we would, on the old subschema, we could say, and this is a change that you could make as part of the actual modification of the database, would be to recode the old subschema to add the elements are clause and just specify record A, field 1, field 2, and field 3, and regenerate that subschema against the new schema. That subschema will then look like the old version of the database. It would only make it look like there were 30 bytes in the record. And that would be great for those programs that are not going to use the record A-field 4. So in that particular case, by creating or modifying the old subschema, I don't have to recompile any programs that do not or will not use Rec A field 4. But now I'm going to create a new subschema. We're just calling it new sub here. And there on that elements statement, elements R, I specify all 4 fields, field 1, field 2, field 3, and field 4. And I create that subschema. Any of the programs that will actually use field 4 will now be modified. Instead of using old sub, they will use new sub, and then when they're recompiled, they will create a 40-byte area for record A. So it minimizes the number of programs that are going to be have to be recompiled as part of that restructure process. Now, non-SQL databases, we're still talking about non-SQL databases here. Many of your non-SQL databases will be used by SQL processes. This is one of the beauties of IDMS, is that we allow SQL processing against non-SQL defined databases. But if you're going to make a change to a non-SQL database that is referenced using SQL, you must make sure that something called an access module is recompiled. Access modules, basically think of them, part of what they contain is the subschema definition plus other information that is used by SQL, but they have got to be regenerated so that they get the new structure of the database for the SQL access process. So any access modules compiled against a non-SQL schema must be regenerated. To do this, you can use OCF online, or you can do it through IDMS BCF. You'll use the alter access module, specifying the access module names. You can also specify version numbers with the replace all command. And then if you're wondering which access modules need to be recompiled, what we have here is a select statement that you could run through OCF or BCF against the catalog, and this would give you a listing of those access modules that you will have to process once you make the changes to the non-SQL database. Now, one of the other items that can be changed within your environment is database procedures. Database procedures are kind of exit routines, special purpose subroutines. They're defined on the schema level, and you can give them specific times to be executed, for example, before an obtain or before a get or after a get, or if there's an error process, what have you. These commands or these routines, as I said, think of them as exit routines. So the DBMS will go through, realize that there's a database procedure defined against a particular record type, and when the specified command is executed, the database management system will make a call to these routines to perform whatever special functions are necessary. These routines can be used for a number of different things. We had one site who dealt with phone processes or phone records and that, and they had some important people, let's say, on that database. But they only wanted certain representatives within their company to be able to handle the accounts for those, so that everybody didn't have access to these people, to their accounts. So they placed a database procedure on there that basically looked and said, okay, who's the user, who is the person on this account? If there was a match, or if this was specified person that was restricted and I didn't match the user ID, it would come through and suppress the access of that record. So only those representatives that were authorized to process something for that person would actually be able to see the records. So these types of things are very transparent to the applications. Also, you can make changes to some of the records. I've known sites that have gone through and put a date timestamp onto each record when it was modified or altered in some way. Y2K, a lot of sites used Y2K to update the dates to make sure that the century information was there. So you can modify these records or just do kind of overview information. One of the types of modification is data compression. So IDMS comp, decomp, their database procedures, and even PressPack works in a similar way to the database processing. Again, these utilities or their exit routines are processed through the schema, and it's in the schema that you will add, change, or remove the database procedure. And when we say change, it might be on the verb or the time relative to the verb that it's going to be executed. Now, to change these database procedures, you're going to want to add, modify, or delete the database procedure. And to do that, let's say you're adding or modifying it, you're certainly going to write, compile, and link the database procedure. Now, if you're just modifying something, in many cases, you just have to deal with the database procedure code and link at it the new load module. You may not even then have to go through and even update anything in the schema, because all you're doing is changing the actual flow or logic within the database procedure. But if you're adding or deleting the database procedure, you're also going to want to update the schema to reflect that database procedure's run or call times and the records that it's associated with, and then of course regenerate all of the affected subschemas. If the database procedure does not alter data on the existing records, you typically do not have to go through and do any type of restructure processing or do anything to the existing data. Just by changing the schema and regenerating the subschemas will implement those changes. However, if that database procedure does make physical changes to the database, for example, compression, let's say you decide to add compression to a record or remove compression, then of course the database procedure is going to have to make physical changes to the database. In that particular case, it is necessary to run the Restructure utility. When you add or delete these database procedures, one of the things that will be generated when you run your IDMS RSTC utility is going to be a new procs parameter on the record statement, the IDMS RSTT record statement, and that is going to specify how the procedures are to be handled. So again, you don't have to make the changes to those RSTT macros. That's something that IDMS RSTC will do for you. So far we've been talking exclusively about non-SQL databases. So we are now going to take a look at the SQL environment, which is a little bit different. Well, I shouldn't even say a little bit different. It's quite different from the non-SQL database. Some of the types of changes, and this by no means is an exclusive list for the types of changes that are made with SQL, but just an example of some of the things that you could do. You might add a column to a table. You might add or drop an index on a given table. You can change a tables from a non-calc record to a calc record. However, to do that, the table must be empty. So that is something that we're going to see may require some additional processing during the actual implementation to get that to occur. You can add or drop a table or add or drop referential constraints. There's other things like you can change the length of a column, You can also drop a column, things of that nature, change the data sets, data types of given columns. So there are a lot more that we don't need to list everything here, but this gives you an idea of the types of things that can be done to an SQL table. Now, the general steps for changing an SQL database is pretty much similar to the non-SQL in that, one, we need to change the definition, and two, we have to change the physical data. And so we're going to take a look at some of those procedures. Now, this first statement is a little misleading. We say SQL database changes require little effort. Well, that's just often little effort on the point of the DBA or the part of the DBA. The DBA is going to get onto the system, and they're going to add they're going to execute an SQL DD statement that is going to indicate the change. It might be create index or alter table, alter column, what have you. So it's a very simple process. You get on, you enter command, and you hit enter. But that doesn't mean that that's all that's going to occur. Some of these commands are going to require a significant amount of runtime and involvement. So that command is going to do two things. It's going to go out and it's going to alter the catalog's definition. And in many of the cases, it's then going to go through and make the change to the database. So it's more or less an in-flight restructure. So if I'm going to make a change to a table, and that table has, say, 2 million rows, when I execute that command, not only am I going to do this quick update to the catalog, but I'm also going to have to make the change to 2 million rows or 2 million records on the database. So that can be a fair amount of processing that is going to occur. So some of the commands, again, not all inclusive, but some of the commands that might require a significant amount of resources, create index. So not only are we going to change the catalog, but we're going to have to go into the database, find all of the rows that are going to be indexed, extract the key information, and then build the index structure. If I drop an index, I'm going to go through and get rid of the index structure, and then I'm going to have to go through and make changes to the individual records, very possibly to eliminate maybe some index pointers. So there's a lot of work that has got to be done. The impact here is, especially on these larger tables, that means if you're doing this in a CV environment, that's going to be journaling, that's going to be going on. It does not do commits during an in-flight restructure. So there can be a lot of updating that goes on there. So we're going to see that a lot of these commands or a lot of this processing, you may want to do them in a local mode environment. So again, for large tables, you want to consider using local mode processing, just because the amount of journaling in a CV environment could fill up your journals and could also generate, well, will generate a lot of locks that could create a problem with the amount of space used for the lock tables. Again, there is no committing during these SQL DDL statements. So very large tables, you certainly want to use local mode. One of the things to remember is that you are updating the catalog and the data. So when you're going to run any type of these commands in local mode, you want to make sure that you vary both the DDL-cat and DDL-cat areas and any of the database areas offline from a CV. Make sure that they're the only copy of IDMS using them, because you're going to update both the catalog and the data, and you have to keep those in sync. So you want to back up all of these areas, the DDL-cat, DDL-cat-X, and the data areas before issuing the SQL DDL statements. You'll issue the SQL DDL statement and then back up the areas after the changes are made. That last point on this slide is something that is very important for you to remember, and that you must protect your catalog. Protecting the catalog, what I mean by protecting your catalog is that it is included with the backup of the database. There are date timestamps in the database and there are date timestamps in the catalog. They must be kept in sync. So if the only thing you do is update the data and then you do the SQL DDL statement and then something happens and you've got to restore that previous environment, you may have an out-of-sync condition between the catalog and the data because you can't restore the catalog back to that same point prior to the SQL DDL statement. And as a result, you're going to have problems and have to take additional steps to correct those errors or those problems that you get because of that out-of-sync condition. Now, some of the things that we want to consider in terms of additional action. Again, not an all-inclusive list, but some of these things that may require additional actions. Adding or removing a calc key from a non-empty table. So we said that to be able to deal with or add calc characteristics to a table, the table must be empty. So we'll talk about that, those types of changes. Adding a linked constraint if either table is not empty. Dropping columns from a table. Changing the data type of a column. Actually, some of the things like changing data type, some of these actually now can be done with some newer alter statements, but in some cases it may be easier with the larger databases to, again, do some of these actions or these procedures that we're going to look at in a second here. And then, of course, adding or removing data compression. So, two approaches that you can use when dealing with some of these actions. The first approach would be to go through, and you've got your old table definitions and all the indexes and constraints and that defined, would be to go through and create a new table that is identical to the existing table except for the desired changes. It may be a different data type. It might be it has a new column in it, or you've dropped an existing column. So create that new table with a different name than the existing table. So again, everything is the same except for the name and the desired changes. And then populate the new table with data from the old table using an insert statement. So what you end up doing is you extract the information using a select statement and then take that information and then do an insert using that. You'll delete the old table, and once that old table is deleted, then you can create a view of the new table that uses the same name as the old table, and you've implemented your changes, and basically you end up getting rid of that old table structure. Now, a second approach would be to offload the data from the table that is being altered and offload that into some type of a sequential file. Once you've got that data extracted from the environment, you can then delete the old table definition and then recreate that particular table using your SQL DDL statement with your changes, and then using the load utility, reload that data from the sequential file into the existing database using the new definition. Okay. Now, approach 2 is probably better for very large tables, because again, you're not you're able to control the various pieces of that, and you're taking that off. You're not going to worry about journaling and locks and things of that matter. If you're making changes to several tables at one time, if you would just go through and do your SQL DDL statements, you'd have to process the database for one change and then do the next table and then do the next table, and each one of those would process the database in its entirety. By using this particular approach, you can extract the data put it into the sequential file, make all of your table changes, and add all of the new the data back into the new defined databases in one pass within that structure. And when you create or preserve linked constraints, this can be, once again, a better approach. Okay, so that concludes the discussion of changing the database. We really are at a point where I think there isn't a nice early cutoff in this recover the database section. So I think what we'll do here is we'll open it for questions. We, of course, want to leave time for that. And I'll pass it back to Len, and you can enter your questions, and we'll answer as many as we can within the time frame.
All right, great. Thanks, Dick. Great job as always. So, so if any of you are on the phone, now will be a time to please hit #6 to unmute your line and ask your questions verbally. Otherwise, please do use the Q&A box right in the WebEx to ask any of your questions, and we'll give you a moment to type those out for us. All right, Dick, we do have a question in the Q&A box, so I'll go ahead and read it. After restructure of utility in the segment database, is there a mandatory to work on unload reload utility build rebuild of index because internally the SR record getting additional added to SR4? I'm not sure if you understand what that question's asking.
Yeah.
Hopefully you do.
Okay. The situation here, I think there are different components within that question that don't really go together. However, let me try and describe. I think what I understand the focus of the question is. When you do a restructure, that restructure is done in place. So at the completion of restructure, that particular database is good to go. It can be processed by application programs, and it's totally intact, and you've got a good database. Now, there are a couple things to consider. First of all, the reference to SR4 records. Restructure will never create any additional SR4 records. So variable length records are not expanded by creations of SR4 records. So I would not expect to see any the number of SR4 records increased. Actually, you may see them decrease a little bit. What you may see within the database are things called SR2 and SR3 records. I mentioned those back, I believe it was on our first webcast when we were looking at some of the print space utilities. The SR2, SR3 records are what are used when we get into some space considerations. So you may see a number of SR2, SR3 records, and if you see large numbers of these on the database, you may want to consider doing an unload reload, and also consider that. Consider that if you're increasing the size of a record by running the restructure utility, you're going to end up using more space in that database. So if that database, after the restructure, is going to be someplace over that 70% threshold that we talked about on day one, you may want to consider doing an unload reload to expand the database to give yourself more space for what you have basically used by doing the restructure. Indexes, when you do a restructure, an index, for the most part, you're not going to basically, you're not going to add, if you add a new index into or through the Restructure utility, that's a change that you made, what you're going to have to do there is either do some type of a maintain index, doing a build from all rows, or have one of the user written programs go through to build that particular index. So Restructure itself does not create a new index structure. You must make some type of additional take some additional steps based on that, either connecting the records into the index using a user written program or running a maintain index to create that index. So I hope I understood the where you were going with the question.
All right, looks like we have another question that just came in. We have an index with thousands of orphans. The area is 685 full, but the print space shows SR8S using 99.89% of the total area. Encountered a DB full error, and the application team had to delete some data, but would a Tune IX help with the space?
Oh, certainly. Well, but was there more? I'm sorry.
Nope, that's it.
Okay. Tune. One of the things that Tune Index will do is resolve orphan conditions. You may see some reclamation of space based on that process, because you can then also rebuild the index. But primarily, if you're seeing an area that is extremely full, just the fact that you have large numbers of orphans, running a Tune index or even a maintain index to rebuild that index structure will resolve the orphan situation and the negative performance impacts that orphans have, but is not necessarily going to give you large amounts of space back to that particular index or the area in which that index resides. So if you're looking at like a 95% full with all these orphans, when you run that run Tune Index to get those orphans back, you're probably going to see someplace still in the upper 80s, upper 90s in terms of utilization, which is going to result in an inefficient database. You should really be looking at that area, that index area, from the standpoint of it's just under allocated, and you should be looking to increase the amount of space in that area, either by increasing the page size of the area or increasing the number of pages in the area, and then doing a maintain index, or certainly you could do an unload reload of the data area that will take care of the index as well. That's it. I'm through. Next question.
A follow-up question to that, is Tune Index available with release 16?
Oh, I'm trying to think back to when Tune Index came in, and I want to say no. I think it came at release 17. I would have to verify that, but I believe it was either 16 or 17. I want to say that it was 17. Right off the top of my head, I can't remember. But if you're on 16, you're running with a very old, unsupported release of IDMS. If you're running with 16, there were lots of patches to Tune Index in the early days, and so you're running with software that's unsupported, and I would certainly make a strong recommendation to get up to 18.5 or 19.0.
All right. I don't see any other questions coming in, so we can probably go ahead and wrap up. Dick, thank you very much. And so everyone on the call knows, as always, a replay of this will be available in the community early next week. So please feel free to, once that's posted, please feel free to share that with your colleagues. And we have, and I believe, Dick, is next week our final one?
Well, I actually would like to see maybe an extended extra week because I think the recovery of the database is going to be more than a 50-minute discussion.
All right. Well,
so
then
we can talk about that afterwards.
Yeah, definitely. All right. So thank you very much, Dick, and thank you for everyone for joining us today, and have a great weekend.